All right, today we're going to be going over Module 3, Lesson 2, over compound interest. Last time we talked about simple interest. We calculated simple interest, which was only calculated on the principal. So the money that we put into the bank, we calculated the interest on that. This time we are going to be compounding that interest. So we are going to be calculating interest on top of the interest that we calculated previously. So the definition of compound interest is interest computed on the original principal as well as on any accumulated interest. We have different compounding periods. So compounding period is the period of time between two interest payments. So you can compound once a year, which is annually, so one time a year. We have semi-annually, which is 2 times a year, quarterly, monthly, and weekly, and daily. So quarterly, there's 4 quarters, there's 12 months in a year, 52 weeks in a year, and then 365 days. Continuous compounding is compounding periods increase infinitely. And then the last definition is the effective annual yield or effective rate. So the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at a stated rate. So we'll talk about this at the end. The formulas that we will be looking at, we have the future value for compound interest. So remember, A is always our future value. So this is whenever we have the different compounding periods, we have now added into our formulas. So we have talked about future value, which is A. P is going to be our principal, so the amount of money that we are putting into the bank or financial institute. R is still going to be our interest rate. T is our time, and then N is going to be our compounding period. So annually, N equals 1, semi-annually, N equals 2, and so forth and so on, all the way down. So N is going to be however often we are compounding. The continuously compounded has its own formula for future value. And then we have the present value. So we're going backwards. We want to figure out how much money we want to put in the bank today to get to a future value amount. So exercise 1. The principal represents an amount of money deposited in a savings account subject to compound interest at a given rate. So we are putting $10,000 into the bank today. We are going to have an interest rate of 4%. So when we put it in our formula, it's going in as 0.04. It's compounded annually, so 1 time a year. Refer to this up here if you need to. So annually, N equals 1. And then time is 2 years. So let me write the future value formula. We are looking for the future value. A equals P, and then we have 1 plus R over N inside our parentheses, and then exponent N times T. So future value A equals, I'm going to plug everything in. We have 10,000 for our principal. 1 plus the interest rate 0.04 divided by 1 for however often it's compounded, and then 1 times 2. Whenever we plug this into our calculator, let me do a couple of these for you. So we have 10,000, open your parentheses, 1 plus, and you can do 0.04 divided by 1, but anytime we divide a number by 1, it is always itself. To do the exponent, we are going to use this button right above our division button. So it's a little caret is what they call it. This button right here will give you the exponent box, and you can type in what we need. 1 times 2, which is just 2. And we get $10,816. So that means after 2 years, we will have this much money in the bank if we have this interest rate and if it's only compounded once a year. So on these questions, they're going to ask you to find the future value and then find the interest earned. So part A is the future value, part B is going to be the interest that you earned. So this future value amount, this is the amount of money that you have in the bank after 2 years. We put $10,000 in. So we need to subtract these two values. So let me write this up here. I is going to equal your future value amount minus your principal. So interest is going to be 10,816 minus 10,000. The interest that we have earned is $816. Okay, the second one. Our principal is 3,000. Our interest rate is 5%, so 0.05. Compounded semi-annually, so twice a year, n equals 2. And then our time is 4 years. So part A is our future value. A equals, we have 3,000, and then 1 plus R over N, so 0.05 divided by 2. Close our parentheses. And then our exponent is going to be n times t, so 2 times 4. Plug it into our calculator. I'm going to go up and highlight this and just reuse it. I'm going to scroll all the way over. So I'm going to delete that. And then we have 3,000. 1 plus 0.05 divided by 2. And then we have 2 times 4 in our exponent. We get 3,655 and 21 cents. So we're going to round to the nearest cent on these, if there is the cents. So 3,655 and 21 cents is our future value. So we are going to have this much money in our account after 4 years. So how much interest did we earn? Let me do equals. We're going to take our future value amount, 36.55 and 21 cents, and subtract the money that we put into the bank. And we have earned $655.21 in interest. All right. So we are going to go through pretty much all of the different compounding periods. We have quarterly and we have daily left for this, and we have continuously for future value. So part A, future value equals 9,500 is our principal. 1 plus R over N, so 0.06. Let me put that right here. Compounded quarterly, N equals 4. So 0.06 divided by 4, and then our exponent is N times T, so 4 times 5. Oh. Let me scroll up, put it in. So, okay, 95 500, 1 plus 0.06 divided by 4, and then we have 4 times 5. We should get 12,795 and 12 cents. So 12,795.12 is our answer for part A, the future value amount. Part B is the interest. We're going to take our future value amount, 12,795 and 12 cents, and subtract the principal. So we put 9,500 in. We have earned 3,295 and 12 cents in interest just for putting that money in the bank. All right, compounded daily. Daily is 365 and equals 365. The rate here is 8.5%, so 0.085. So let's see. Future value equals, we have $1,500 that we're putting in. 1 plus R over N, so 0.085 divided by 365. Our exponent is 365 times 2.5. I'm going to put it into our calculator. So our amount is 1,500. 1 plus 0.08. I need to second and insert right here. 0.085 divided by 365. So I need to insert another number. Okay. And then our exponent, 365 times 2.5, and we should get $18.55 and 10 cents. So 1855.10 is our future value for our interest. We have 1855.10 minus 1,500. We have earned $355.10 in interest. All right, the last one for future value, we are compounding it continuously. The formula for the compounding continuously is different. We have P, E, and then RT for the exponent. So I will show you how to do this in the calculator. So part A, our future value, the principal is 12,000, and E, and then R is going to be, so we have 6.85%, so 0.0685 times our time of 3 years. Now, when you put this into the calculator, we're not going to use that same formula. We have E. E is kind of like pi. You can consider it similar to pi. So we have 12,000, and there's a button that we can use. It is this LN button, but we want E to the power of X. And they will let us change that. So we're going to click second and then LN, and that gives us our E with our exponent box. So then we can put in our exponent, so 0.0685 times 3, And we get 14,737.67. So 14,737 and 67 cents is our future value. For our interest, we are going to take 14,737.67, subtract 12,000, the money that we put in the account, and we should get interest of 2,737 and 67 cents. All right, the next exercise, calculate the principal or present value. So these are both going to be the letter P. So it says how much money should be deposited today. So anytime it says that, we know that we're looking for our present value or a principal. How much money should be deposited today in an account that earns 6% compounded semi-annually so that it will accumulate to 10,000 in 3 years. So it gives us everything we need to know. R equals 6%, so 0.06. Semi-annually is twice a year, so N equals 2. And then we have our future value of 10,000 and our time of 3 years. So we're going to use the formula for P. P equals A divided by 1 plus R over N to the NT power. So P equals, we have 10,000 divided by 1 plus R over N, so 0.06 divided by 2. We have 6% compounded semi-annually, so twice a year. And then to the NT power, so 2 times 3 years. Let's put it into our calculator. On this one, I'm going to create a fraction. So alpha, y equals, and then enter, gives us our fraction boxes. I can put 10,000 on top. And then we need parentheses, so 1 plus 0.06 divided by 2. Close our parentheses. We need our exponent box, 2 times 3. So we get 8,374 and 84 cents. So you'll have to read your rounding directions. If we were to round normal, it would be 8,374.84. If it tells us to round up, then you will put 8,374.85. Okay. And then if it asks you for your interest, I don't think it does, but let's go ahead and calculate it. Our interest, we're still taking our future value amount, 10,000, subtracting our P, which is 8374.85. $16.25 and 15 cents. 1625.15. Okay, I don't think it asks for the interest, but just in case, you know that interest is always going to be your future value minus the principal. So let me write that up here. I'm going to put interest earned, I equals future value minus P. All right, on B, how much money should be deposited today in an account that earns 9.5% compounded monthly so that it will accumulate to $10,000 in 3 years? So 9.5%, R equals 0.095, compounded monthly, N equals 12. Our future value is 10,000, and then the time is 3 years. So P equals, we have 10,000, so similar to the one that we just did, but this one was compounded semi-annually and the rate was a little bit lower. So 10,000, and then we have 1 plus 0.095 divided by 12. We have R over N, and then our exponent 12 times 3. So let me plug this up. I'm going to go up and highlight, click enter, and we just need to change our pieces. We still have 10,000, we still have the 1 plus, and then we have 0.095 divided by 12. Let me go back. Close our parentheses. Okay. And then our exponent is 12 times 3. And you should get 7,528 and 59 cents. 7,528 and 59 cents. All right, the last part is going to be the effective annual yield. So we're going to use this Y equals 1 plus R over N to the N power all minus 1. So it says a passbook savings account has a rate of 6%, so R equals 0.06. It says find the effective annual yield rounded to the nearest tenth of a percent. So we're going to calculate, and it's going to give us our answer as a decimal, and we want to put that as a percent. So don't forget at the end, we're going to turn it into a percent. So if it says if the interest is compounded ... So we have semi-annually, quarterly, and then monthly. So semi-annually is twice a year, N equals 2. So Y equals 1 plus R over N, so 0.06 divided by 2 to the second power, all minus 1. Okay, so I've got 1 plus 0.06 divided by 2. Close our parentheses. We're going to have our exponent squared, and then minus 1 gives us 0.0609. 0.0609. So remember, we want to turn this back into a percent. So we have 6.09%, and I think it said to the nearest tenth, so it's going to be 6.1%. All right, on B, quarterly, 4 quarters in a year, so N equals 4. Y equals 1 plus 0.06 divided by 4 to the fourth minus 1. Go up and highlight, click enter, and all I have to change is the N. And we get 0.0614. Okay. 0.0614, which rounds to 6.1% again. All right, and then our last one is monthly. So monthly, there's 12 months in a year, N equals 12. y equals 1 plus 0.06 divided by 12 to the 12th minus 1. Enter. All we're changing is the n. Okay, and then to the 12th power gives us 0.0617, so 0.062. So 0.0617 rounds to 6.2%.